My name is Sadie, and I'm going to be presenting on the ESKAPE pathogens. What are the ESKAPE pathogens? They're 6 gram-positive and negative multi-drug resistant bacteria listed by the World Health Organization as priority pathogens, basically meaning that the research and development of new antibiotics should be focused on these 6 pathogens, which include 2 gram-positive bacteria, Staphylococcus aureus, and 2 Enterococcus species, and 4 gram-negative bacteria, including E. coli, Klebsiella pneumoniae, Acinetobacter, and Pseudomonas aeruginosa. The biggest danger is that they're highly opportunistic pathogens, which are often implicated in hospital and community-acquired infections, and they typically target immunocompromised patients. These multi-drug resistant bacteria are responsible for over 60,000 deaths in the US and Europe every single year. They're resistant to both first-line antibiotics and last-line antibiotics. One of the biggest issues that arises with multi-drug resistant bacteria is that providers will mistakenly empirically prescribe these antibiotics, not knowing that they're resistant to them, which only adds on to resistance rather than obtaining a culture, which may describe the bacteria to them and prevent them from prescribing more. These bacteria often have differing methods of resistance, including antibiotic inactivation, which could also include alteration of target sites, such as the cleavage of the beta-lactam ring by beta-lactamases. They could affect the target site. Efflux pumps, porins, and biofilm production are also implicated in resistance. For example, efflux pumps allow antibiotics to be pumped out of the cell. Porins allow the entry of antibiotics in the outer membranes of gram-resistant bacteria, but multi-drug resistant bacteria will have a reduction in their number, allowing less antibiotics to go through. Biofilms are formed when bacteria clump up and aggregate in certain areas. An example that we spoke about in class was in patients with cystic fibrosis. They're typically infected with Pseudomonas aeruginosa, which can accumulate in their lungs. There are different novel therapies that have been discussed as an alternative to antibiotics. These include combination treatment with 2 different mechanisms of actions of antibiotics. Bacteriophages are another proposed treatment, although there's a concern with growing resistant to them. De novo drug discovery involves repurposing drugs. For example, Copaxone is used against multiple sclerosis, but it's actually been shown to be effective against E. coli, Acinetobacter, and Pseudomonas aeruginosa. Monoclonal antibodies are specific and beneficially they won't target the host microbiome. They also hold a low chance for resistance. And lastly, there are many vaccine candidates for these bacteria, but they have failed to elicit an immunogenic protective effect in varying clinical trials. Pfizer in 2018 did have a phase 1 and 2 clinical trial against Staph aureus, and it did demonstrate efficacy in the prevention of invasive Staph aureus infections in humans, but in December 2018, they stopped enrollment.